This is a math attack, and this is a math attack. Make sure you hit that little like button down there.
Hey folks, welcome to Polynomial Land. So this is lesson 1 of the Quadratics unit. So welcome to the term. So for example, if I have 3x squared, the 3 is the coefficient, the x is a variable, and the 2 is the exponent. So the little 2 at the top is the exponent. So variables are symbols or letters that represent a value. So the most common variables that we will be seeing is x, y, z, a, b, c, s, t, u, and v. We're going to do a little example using pictures here. So let's say I have 15 M&M cookies, and then a friend gives me another 9 M&M cookies. That would mean I then have a total of 24 M&M cookies. Okay, but what if the cookies are different? So let's say I have 15 M&M cookies, but then a friend gives me 9 chocolate chip cookies. I can't say then I have 24 M&M chocolate chip cookies. I would keep it as I have 15 M&M cookies and 9 chocolate chip, because the M&M and the chocolate chip are two totally different cookies. So the quintessential rules of algebra. So add and subtract terms, so only when the letters and exponents, so keyword there is and. So the letters and the exponents have to be exactly the same. So for example, if I have 3x plus 2y, well, my variable for the 3 is an x, and then for the 2 it's a y. They are not the same letters. Therefore, we cannot add them together, and we just leave it as 3x plus 2y. Well, let's say that we have 3x plus 2x. Well, the letters are the same, they're both x, and they both have an imaginary exponent of 1. Therefore, we can add them together. So if we have 3x's plus 2x's, then I have a total of 5x's. Another example. So remember, the exponents have to be exactly the same. So if I have 3x plus 2x squared, well, the first x is x to the imaginary power of 1. The second is to the power of 2. These are not the same terms, so we cannot add them together. So I would just leave it as it is, as 3x plus 2x squared. Then another example, if I have 3x squared plus 2x squared, well, the terms are exactly the same because we have x squared and x squared. Therefore, we can add those together and get 5x squared. Okay, so when we're multiplying and dividing terms, we're going to multiply and divide any and all. So for example, if I have 3x times 2x, well, no matter what, we're going to be doing the multiplication, but we need to take into consideration the exponent laws here. So if I'm multiplying an x with an imaginary power to 1 times another x to the imaginary power of 1, we've got to use our exponent laws where when we multiply it, we're going to add the exponents together. What we also need to do, though, is the coefficients that are sitting out front of those variables, we need to multiply them together. So I get 6x squared. So 3 times 2, I get 6, and then with the imaginary 1 on each, when you add them together, you're going to get x squared. So 6x squared is the final answer there. Another example, if I have 3x and 2y, so we can't add the variable exponents together here for the variables because they are not the same. We do still have to put them together. So the first thing you want to do is take the coefficients and multiply them together. So again, 3 times 2, we get 6. And then because x and y are not the same, we just put them next to each other. So the final answer is 6xy. Okay, so let's simplify some examples. So for A, we've got 4x plus 3x plus 2x squared. So our only like terms here is the 4x and the 3x because they are the same variable and they have the same exponent of the imaginary 1. So we can add those two together. So if I have 4x and then I have 3x, put them together, we're going to have 7x, and then we just leave the 2x squared at the end. We can't simplify this any more than that. Okay, so for B, I have 5x squared minus 3x plus 1. Here we don't have any term that is like. This is x squared, this is x with the imaginary exponent 1, and this doesn't even have a variable on it. So this one cannot be simplified anymore, so we would leave it as 5x squared minus 3x plus 1. Okay, so then for C, we have 2wy plus 5yw. So when exponents are not exponents, when variables are multiplied together, they can be switched around. So wy is the same thing as writing 2yw, and 5yw is the same thing as adding 5wy. Okay, so let's just change one of those. Let's keep 2yw the same and switch 5w and y around. So now our variables are the same. It's wy with the same exponent, so we can add them together. So I'd get 7wy. Then for D, our only like terms here, so we have 12x plus 2x minus 5xy are these two. So the 12x plus 2x would give me 14x, and because there is a y involved in this term, because it's 5xy, we can't, they're not like terms, so we can't subtract it or add it together. So we're just going to leave it as add the x to the 14 and then minus 5xy.